My Weird School Fast Facts. Space, Humans, and Farts. Written by Dan Gutman. Pictures by Jim Pellot. Chapter 6. Forces and Machines. A force is something that pushes or pulls on objects. Okay, that makes no sense at all. Maybe I can explain, Arlo. Gravity is a force that makes things fall toward the earth. It pulls us down. If it wasn't for gravity, we'd all be floating around in space. That would be cool. It would be like when astronauts float around inside the space station. Yes, they're weightless. But they haven't completely escaped the Earth's gravity, because it's gravity that holds the space station in orbit. If we were on the moon right now, we would be able to jump a lot higher and farther. The force of gravity is weaker there because the moon is smaller and lighter than the Earth. But it's still pretty strong. It's so strong that the moon controls the tides in our oceans. How does that work, Mr. Docker? The moon's gravity pulls on the water in the ocean. Let's say the moon is overhead. That's when the water rises up, like it's trying to go to the moon. It's high tide. When the moon is on the other side of the earth, the ocean slinks back. It's low tide. About every 12 hours, the water level in the ocean rises and falls. Do small objects have gravity too? Sure, if you drop a book on the floor, the earth is pulling on the book. But the book is also pulling on the earth to meet it, just a little bit. So I guess a little magnet has enough force to overcome all the earth's gravity, right? If it didn't, how would it stick to a refrigerator? That's right, AJ. And gravity is just one force. We can use other forces to do things we can't do on our own, sometimes with the help of machines. Anything that lets us take small forces and turn them into big forces is a machine. Gears, wheels, pulleys, and screws are all simple machines. We don't need fuel to run them. Do you know what a lever is? Sure, that's when you go to school in the morning and you say goodbye to your mom. You leave her. No, dumbhead. A lever is a kind of machine. A seesaw is a lever, right, Mr. Docker? Right. Let's say your dad weighs 200 pounds. He's too heavy for you to pick him up. But if you sit at one end of a seesaw and your dad sits at the other end, it would be possible to pick him up if you placed the balancing point far enough away from you. So if you had a lever big enough, you could pick up the earth. But that would be weird. Let's look at another force. Do you kids know what friction is? Sure. It's the opposite of non-friction. It's a made-up story. Mrs. Rupee taught us that in the library. No, dumbhead. Friction is a force that happens when two objects move against each other. It's the force that makes the motion harder. That's right, Andrea. Rub your hands together for a few seconds. They feel warm, right? That's because of friction. The rougher the surface, the more friction. And the more friction, the more heat. Sandpaper has a lot of friction. Ice has very little, so we can slip on it. If there isn't any friction, the two things slide easily. I'll bet you don't know this fast fact. When you go ice skating, the ice melts a tiny bit as you slide over it. Look it up if you don't believe me. I'll bet you don't know this fast fact. There's a plant called the pitcher plant that is one of the slipperiest things in the world. When an insect climbs inside a pitcher plant, the side is so slippery that the insect can't get out. Then it gets eaten by the plant, a plant that eats animals. That's a switch. If you ask me, that should be called a catcher plant instead of a pitcher plant. Speaking of forces, did you kids ever wonder how a plane can get off the ground? Some of them weigh hundreds of tons. It must be magic. It's not magic, Arlo. As the plane rushes down the runway really fast, air rushes over the wings. The wings are curved, making the air faster and the pressure lower above the wing than below it. And that creates an upward force called lift. I knew that. And here is a fast fact I bet you don't know. Racing cars work the same way, but upside down. They're designed so that the air rushing by pushes them against the road so they can go fast around turns. Some racing cars can go so fast that they would be able to drive upside down on the ceiling. Try this. You can demonstrate lift by sticking your hand out of your car window while your mom or dad is driving down the highway. Only do this if there are no cars passing by. Change the angle of your hand and feel it get pushed up or down. Wait a minute. Helicopters don't rush down a runway. How did they get off the ground? Helicopters create lift the same way. But instead of having fixed wings, like a plane, they have rotors that spin around. The rotors are like spinning wings. Oh yeah? Then what about rockets? They don't rush down a runway, and they don't have wings or rotors either. Rockets use a high-speed blast of burning fuel to create hot gases under pressure. The gases fire backward from the engines to push the rocket upward and into outer space. It's sort of like when you let the air out of a balloon and the balloon shoots in the opposite direction, right? Exactly. Rockets and many other machines create the energy they need by burning fossil fuels, oil, coal, and natural gas. That's how we can drive cars, heat our houses, turn on electrical appliances, cook food, charge our phones, and so on. The problem is that burning fossil fuel gives off greenhouse gases, and that heats up the atmosphere. I always hear about the atmosphere, but I never really knew what it meant. The atmosphere is the layer of air that surrounds the Earth. It extends 300 miles into space, but most of it is only 10 miles deep. That's pretty thin. So if we heat up our atmosphere by continuing to burn fossil fuels, then the ice caps melt, oceans rise, species die out, and soon we will be in real trouble. So what can we do about it? Gradually, the nations of the world are coming together to make the switch to sources of energy that don't involve burning. Solar energy, wind, nuclear energy. We can also create energy by harnessing the power of the tides. We can tap into the heat of the Earth's core to generate geothermal energy. We can use hydrogen. We need a lot of energy, and there are a lot of ways to get it other than by burning things. That reminds me,